Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Triangles and Their Sides, Triangle Inequality Theorem. Alright, what is the Triangle Inequality Theorem? Let's take a look at this. The sum of the lengths of any two sides is greater than the length of the third side. So what does this mean? Well, generically speaking, if I have a triangle, let's just call their sides A, B, and C for lack of better choices. Here's what the triangle inequality theorem means. It means any which way that I add two sides, it has to be greater than the third side. So A plus B would have to be greater than C, but also B plus C would have to be greater than A, and then finally A plus C would have to be greater than B. Let's take a look at an example with actual real numbers. Here you can see you have a triangle with measures 16 yards, 11 yards, 22 yards. Let's test the triangle inequality theorem, see if it works. 16 plus 11 is going to need to be greater than 22. Now, is it actually going to be greater? Let's find out, and I hope you guys are writing this down as I showed these numbers here. 16 plus 11 is 27. Is 27 greater than 22? Well, indeed it is. So we're going to go ahead and put a check mark next to that because that checked out. But there's other ways we should test this. What about taking 11 plus 22? Those two sides should add up to be greater than 16. Now, I put a question mark here. Is it actually greater? Well, pretty simply we can find out. 11 plus 22 is 33. That definitely is greater than 16. So another one checks off. But what about the third possible way of adding two sides? I already did a 16 plus 11. I already did 11 plus 22. Well, now I need to do 16 plus 22. So let's take a look at that. 16 plus 22, that needs to be greater than 11. Is it? Well, definitely it is. 16 plus 22 is 38. That is greater than 11. Again, I hope you're writing all these down, filling in the blanks as I go through this. Yet another one that is going to check out. And so as you can see, all three ways of adding the lengths of two sides gave a sum that is greater than the length of the third side. This is what the triangle inequality theorem is all about. And it should work for any triangle. In fact, it will work for any triangle. In fact, we can now do a question like number one. Which of the following can be lengths of the sides of a triangle? We have to find out which one will the triangle inequality theorem work all three possible ways of doing this. So let's go ahead and try this together. Is it choice A? Well, if these were angles, then yeah, 30 plus 60 plus 90 would be 180 degrees. And that would be what we would want for angles of a triangle. But no, not for this problem. This said sides, so we are using the triangle inequality theorem. That's what you use for sides of a triangle. So let's test this out. Is 30 plus 60, is it greater than 90? And again, I'm putting a question mark above that greater than symbol because I haven't quite yet figured out if this is going to work. 30 plus 60 is 90. Is that greater than 90? I got news for you. 90 is not greater than itself. This greater than symbol did not have an equal to bar underneath. Did not. And that's why I'm putting a slash through this. I'm saying 90 is not greater than 90. So I don't have to go any further. I don't have to do 60 plus 90 being greater than 30. I don't have to do 30 plus 90 greater than 60. I don't have to do the other two ways because this way did not work. And therefore, choice A is not a possible choice for three sides of a triangle. Goodbye, choice A. All right, what about choice B? Let's test it out. 36 plus 15, is it greater than 19? Again, you're writing this work down. Well, 36 plus 15 is 51. That is greater than 19, so that one checks out. But we got to keep going. What about other ways of doing this? Instead of 36 plus 15, what if I do 15 plus 19? Is that greater than 36? Let's find out. 15 plus 19 is 34. 34 is not greater than 36. So you all know what this means. This cannot be three sides of a triangle. Even though the first way that I tried worked, the next one didn't. So I'm going to stop right there with my work for choice B. It is not going to be three sides of a triangle. All right, what about choice C? Is 28 plus 55 greater than 89? Let's find out. 28 plus 55 is 83. Nope, that is not greater than 89, so goodbye choice C. What about choice? Well, I hope choice D is right, because otherwise I created a problem where none of the answer choices would work, which, by the way, would be hilarious, but let's check this out. Choice D, is 37 plus 46 greater than 22? And again, you're writing all this down. If I'm going too fast for you, feel free to hit pause at any moment to kind of catch up writing this down. 37 plus 46 is 83. That is definitely greater than 22, so that one checks out. What else should I try? What about 46 plus 22? Is that greater than 37? Well, 46 is already bigger than 37, so yeah, I mean, this is definitely going to work. This is going to give me 68. That's definitely greater than 37, so that checks out. And the final way I haven't tried yet is taking 37 plus 22, the first number plus the third number, and see if it's greater than the second. So let's write that down. 37 plus 22, is that greater than 46? Well, 37 plus 22 is 59. That is greater than the 46. So all three ways of trying out the triangle inequality theorem worked, and that is why choice D can be three sides, the lengths of the sides of a triangle. All right, I would like for you to try a problem similar to what I just did on your own. So hit pause on the video. Hit pause now. I've heard some kids are using my videos and they're never hitting pause to try problems on their own. That's not good. So make sure you hit pause now. Try number 2 on your own, and then when you're done, then hit play when you're ready to see how you did. So try number 2 right now on your own. All right, did you already try number 2 on your own? If not, you better do it now because I'm about to go over it. Will choice A work? Well, 20 plus 60 is 80. That is not greater than 100, so goodbye choice A. What about choice B? Well, 77 plus 44 is greater than 61. That one checks out because 121 is greater than 61. What about 44 plus 61? Is that greater than 77? Well, yes it is. Gives me 105. That one checks out. And then the final way of trying it, 77 plus 61, is it greater than 44? Yes, it is. All three ways check out for choice B, and that's why choice B is the correct answer for this problem. It has three sides that could be lengths of a triangle. By the way, choice C did not work out. As soon as I tried 53 plus 24, it gave me 77. We talked about this on choice A of number 1. A number is not greater than itself. It's not. This greater than symbol does not have an equal to bar. So if you get the same number on the left as you have on the right, that's no good for triangle inequality theorem because this is supposed to be greater than, not equal to. Choice D, the first way that if you just try it in order, it works. But as soon as you try 11 plus 3, this is not going to be greater than 18. And from this point on, I should probably mention, you are allowed to work smarter, not harder. And what I mean by that is, if you were doing the work for choice D on your own, and hopefully you all did, you can go ahead and try the way that you know is not going to work. If you can see it with your own eyes, 11 plus 3, you know that's not going to be greater than 18, then you can ignore the work that does work and just start with the one that doesn't to save yourself a little bit of time in writing to get the problem done. All right, let's turn the page. Let's switch it up here. What if I only give you 2 side lengths of a triangle and you are trying to find the unknown length of the third side? So you can see here, the problem says, what range of values can the unknown side, and here I called that n, if you look here on the drawing, that's called n. What range of values can n be? Can a third side be? Well, we're not going to recreate the math here. The same rule that we've been using so far for side lengths of a triangle, which is called the triangle inequality theorem, we're still going to use that. So here's what I mean. We know 39 plus 66 has to be greater than the third side. Well, the third side is called n. So what if it's a variable? It does not change the math. By the way, I hope you're all writing this down as I go through this. Fill in the blanks. 39 plus 66 is 105. So that means 105 is greater than n. And if I rewrite this with the n on the left side, as I normally end up doing, then I would say n is less than 105. I apologize for not having that typed out for you. No big deal. But we do like to have the variable over on the left, so I just do a quick switcheroo, and I see n is less than 105. But that's not the only way of doing the triangle inequality theorem. We also know that 39 plus n should be greater than 66. Now, how do I solve for n on this one? N's not by itself here. It was over here on this first one, but over here it's not. It's being added by 39. Well, we all know the inverse of adding by 39 is subtracting by 39. Do it on both sides, as you've learned with algebra. That'll give us n by itself. 66 minus 39 is 27. So I knew that n had to be less than 105. Now I know n has to be greater than 27. But there's a third way. 66 plus n should be greater than 39. But let me stop this right here. Do I really need to do the work for this one like I did for the other one? Let's work smarter, not harder. You all see 66 by itself, even without even looking at n, 66 by itself is greater than 39. So unless n is a negative, there's no way this couldn't work. So I'm not going to bother finishing this one. Since the first number is already greater than the number to the right, I don't really need to do any more work here for this problem here on the right. In fact, I could have just ignored it altogether and just stuck with the two parts here to the range that I already have. Okay? We know n is less than 105. We know that n is greater than 27. So let's answer the question. What's the range of values? We know that the unknown side that we called n is going to be between, fill that blank in please, between 27 and 105. And let's go ahead and put the unit of measure. We did have units of measure here, and that was feet. So, moral of the story, if n is less than a number, but it's greater than another number, then it's got to be between those two numbers. So that's the range of values that n could be. And you can use that similar process to do a problem like number 3. Which of the following could be the value of n? Show the same work that you were showing before. How 71 plus 85, the two sides here that we're given measures of, has to be greater than n. But we also know 71 plus n has to be greater than 85. Now, I'm not going to bother doing the third way. 85 is already bigger than 71, so I don't need to put 85 plus n is greater than 71. Remember how I didn't have to do the third one over here, where the number here was already bigger than this one on the right? So similar here on number 3, I only have to do the two that I'm showing you here. You don't have to do the third one. All right, so go ahead, hit pause. Finish the work that I've already started for you here on number 3. And then choose the answer choice that is correct, A, B, C, or D, that you saw here on this slide. So hit pause now, finish your work, and then figure out the correct answer for number 3. All right, did you already finish the work? If not, please hit pause now and hit play when you're done with the work. Because here we go. 71 plus 85, that's 156. And if 156 is greater than n, then that means n is less than 156. But what about the other one? 71 plus n greater than 85. Let's get the n by itself. So do the inverse of adding, which is subtracting, and that's going to give me 14. So here's what I know. N's greater than 14, but n is also less than 156. So it has to be between 14 and 156. So which one is between 14 and 156? Well, it's not 14 and it's not 156. Between does not mean equal. Notice there's no equal bar here. N is greater than 14. N is less than 156. There's no equal to bars. So I can cross out the ones that were equal. I need the ones that are in between. Well, that would be 124, not 175. 175 is too big. The biggest it's allowed to be is 150. Actually, it has to be less than 156. So 175 definitely does not work. 124 is the correct answer. All right, I believe there are a few more problems here to go. There's number 4, there's number 5, And finally, there is also number 6. So go ahead and try those 3 problems on your own, and then hit play when you're ready to see how you did. So again, hit pause now, try 4, 5, and 6 on your own, then hit play when you're ready to see how you did. All right, did you already try 4, 5, and 6 on your own? If not, you better hit pause now. All right, number 4. It's another one of these problems, kind of like number 3, except this time it said which of the following could not be the value of n, which kind of implies 3 of them could be the value, but 1 of them could not. And we're looking for the one that could not. All right, so first things first, let's do the same work we were doing before. We know 42 plus 54 has to be greater than the third side. So add those together. That's going to give you 96 is greater than n, which means n is less than 96. But also 42 plus n is greater than 54. Subtract 42 on both sides. That's going to give you n is greater than 12. So we need something that is between 12 and 96. Between 12 and 96. But remember, we're looking for which one is not going to be the value of n. So which one is not between 12 and 96? Well, lo and behold, it's 96, because 96 is equal to 96. All these others, 20, 30, and 75, are between 12 and 96. We're looking for the one that's not going to work, so that is choice D. All right, problem number 5. This time there's no picture. They're just telling us 2 sides of the triangle are 28 and 50. Which one could be? So this one is kind of like number 3, could be. We're not looking for what could not be like number 4. This one is like number 3, could be the length. All right, so here's our work once again. Take the 2 sides that were given, add them together. That means n is less than 78. Then 28 plus n greater than 50, subtract by 28 on both sides, n is greater than 22. So we know that the third side, which I'm calling n just out of habit, must be between 22 and 78. So which one is between 22 and 78? It's not 102. It's definitely not 78. It cannot be equal. I keep talking about that. Cannot be equal. 85 is also too high. Ding, 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 ding. It is the 25, choice B. That one is between 22 and 78. All right, finally, problem number 6. I'm changing the game on you here. Now we're talking about 2 angles. Notice they are degrees. Which of the following could be the measure of the third angle? So completely ignore the triangle inequality theorem. If you go back to the title of your notes, I called it triangles and their sides. Well, angles have a different rule. What do we know about angles? We know that the sum of the 3 angles, call the third one x if you want, the sum of the 3 angles is equal to 180 degrees. That's right. We talked about this on a previous packet of guided notes. So this has nothing to do with doing triangle inequality theorem with greater than symbols. It has nothing to do with that. Let's add 28 and 50. That gives me 78. Then subtract that from 180. Now, by the way, you don't have to show this type of work with an equation. If you just want to go ahead and show that you took 28 and 50, added them together, and got 78, and then subtracted that 78 from 180, there's nothing wrong with that. You could show that work without doing it in the style of an equation. Let me finish this. 180 minus 78 gives me 102 degrees, and so naturally, choice A is the correct answer. So always make sure you're reading the problem. If it's angles, the sum of the angles of any triangle, all 3 of them, have to equal 180 degrees, the sum of those 3. But if it's sides of a triangle, then the sum of any 2 sides must be greater than the length of the third side. And that's 3 different ways you would normally look at that to figure that out. All right, thanks for watching this video. We'll see you next time.